Class 11th, Subject Physics, 7th chapter, Thermal Properties of Matter. Thermal Properties of Matter. From this chapter, let us see change of state. So in this point, we will have to study the change of state of any substance. We know that matter exists in three states such as solid, liquid and gas. So solid, liquid and gas, these are the three states of matter. That means the matter exists in these three states. The conversion from one of these states into another is called as change of state. So when the substance gets converted from one of these states into another, that is called as the change of state of that substance. Then the two common changes of the states are solid to liquid and liquid to gas. So two commonly studied changes of states are from solid state to liquid state and from liquid state to gaseous state and vice versa. Now these changes can occur with exchange of heat which takes place between the substance and its surrounding. So there will be change in the state of any substance due to the exchange of heat energy which takes place between that substance and its surrounding. That means if there is exchange of heat energy between the substance and its surroundings, at that time there will be conversion from one state to another state of that substance. That is, change of state of that substance will take place. In order to explain this conversion or the change of state of any substance, let us consider the variation of temperature with time. So when some temperature, that is heat energy, is supplied to any substance, then at each and every time interval we will have to study the changes in that state, and therefore let us consider the variation of temperature with time. That means a graph of temperature in terms of degree Celsius and time in terms of second will be plotted for any substance. If the temperature against time graph is plotted, then the nature of the graph is as shown. That means it will vary from A to B, B to C, D to D and so on. So like this variation of temperature against time graph will be shown here. Then let us consider the observations of this graph, and therefore we will have to analyze these observations, and therefore let us consider the analysis of the observations from this graph. We will now analyze these observations for two different stages. First stage will be from point A to point B, and then from point B to point D. So if you consider the first stage, that is from point A to point B, here there will be solid state, here there will be just a conversion into liquid state. So above this, for this point or this portion CD, there will be conversion from liquid state to vapor state, liquid state to vapor state. And therefore let us consider first point, that is analysis of observations from point A to B. So for this portion AB, we will analyze these observations. Now for this point from A to B, the observations are stated as: first, the change of state from solid to liquid is called as melting, and from liquid to solid is called as solidification. The change of state from solid state to liquid state is called as melting, and from liquid state to solid state is called as solidification. Second, both the solid and liquid states of the substance coexist in thermal equilibrium during the change of states from solid to liquid or vice versa. both the solid and liquid states of the substance coexist in thermal equilibrium during the change of states from solid to liquid or vice versa. So for this portion AB, there will be change from solid to liquid or from liquid to solid. At that time, these two will coexist in equilibrium, that is the thermal equilibrium. That means temperature will be constant for this portion AB. Then third, the temperature at which the solid and the liquid states of the substance are in thermal equilibrium with each other is called as melting point of the solid or the freezing point of the liquid. The temperature at which the solid and the liquid states of the substance are in thermal equilibrium with each other is called as melting point of the solid or the freezing point of the liquid, and it is the characteristics of the substance and also depends on the pressure. Fourth point, the melting point of the substance at one standard atmospheric pressure is called as normal melting point. The melting point of the substance at one standard atmospheric pressure is called as normal melting point. So this will be the normal melting point. It will be at any one standard atmospheric pressure. Then fifth point will be at one standard atmospheric pressure. At one standard atmospheric pressure, the freezing point of water and melting point of ice are 0 degrees Celsius or 32 degree Fahrenheit. At one standard atmospheric pressure, the freezing point of water and melting point of ice are 0 degrees Celsius or 32 degree Fahrenheit. The freezing point describes the liquid to solid conversion and melting point describes solid to liquid conversion. Thus, at the melting point, the solid will get converted into liquid, and at the freezing point, the liquid will get converted into solid. So this will be regarding the first point, that is analysis of the observations from point A to point B. And now let us consider the second point, that is analysis of the observations from point B to point D. So from point B to point D, what will be the analysis of these observations? Then for this, let us consider the first point. The change of state from liquid to vapor is called as vaporization, while that from vapor to liquid is called as condensation. The change of state from liquid state to vapor state is called as vaporization, and the conversion from vapor state to liquid state is called as condensation. Then second point, both the liquid and vapor states of the substance coexist in thermal equilibrium during the change of state from liquid to vapor. Both the liquid and vapor states of the substance coexist in thermal equilibrium during the change of state from liquid to vapor. Third point, the temperature at which the liquid and the vapor states of the substance coexist is called as boiling point of that liquid. The temperature at which the liquid and vapor states of the substance coexist is called as boiling point of the liquid. That is, at the boiling point of the liquid state and vapor state of that substance will coexist. Then fourth point will be stated as the boiling point of a substance at one standard atmospheric pressure is called its normal boiling point. The boiling point of a substance at one standard atmospheric pressure is called its normal boiling point. So these are some of the observations for this temperature against time graph. Now let us see the next phenomenon, which is called as sublimation. Now let us see what is that sublimation. So in short, it is direct conversion of solid state to vapor state. So we know that all substances do not pass through the three states. All the substances when they are heated will not pass through the three states, solid to liquid, liquid to gas, like this. There are certain substances which are normally passing from the solid state to vapor state directly and vice versa. There are some of the certain substances which normally pass from the solid state to vapor state directly and vice versa, that is from vapor state to solid state. The change from solid state to vapor state without passing through the liquid state is called as sublimation. The change from solid state to vapor state without passing through the liquid state is called as sublimation, and the substance which shows the property of sublimation is called as sublime. That substance is called as sublime. For example, if you consider dry ice, that is solid carbon dioxide, solid CO2, it is termed as dry ice. It will be showing the sublimation. Similarly, iodine, it will also act as sublime. So dry ice and iodine will act as sublime. During the sublimation process, both the solid and vapor states of a substance coexist in thermal equilibrium. During the sublimation of any substance, both solid state and vapor states of the substance coexist in thermal equilibrium, and most of the substances sublime at very low pressures. Most of the substances sublime at very low pressures. So this will be regarding sublimation.